Bonus video. I thought I'd give you a little information why some of the trigonometric functions function as they do. First things first, do remember that we're basing everything on triangles. Trigonometric. Okay? Triangle measurements. And so in the case of our x comma y, we had this point here where we can go over to get there, that's x, up to get there, that's y, and in this case we can call it the hypotenuse, or we can call it the radius, because if we swing this line around, we make a circle. That's why these are also called circular functions. Circular functions, and this word is going to become important. Circular function, because these triangles are all contained within circles. It's a unit circle if the radius happens to equal 1. And that's why when your calculator spits out sine of 15 degrees, you'll notice it's always a decimal. Because what it's saying is, whatever the opposite side is over the hypotenuse, since the hypotenuse is always equal to 1 in a unit circle, that means that the opposite side has a length of 0.2588. So you'll notice if the hypotenuse is always the biggest, and it's 1, every other side is going to be smaller than 1. Every sine, every cosine is, and every secant cos, well no, every sine cosine is going to be smaller than 1 because that's the ratio it is. So that's why sines and cosine ratios are 0.2588. It's because if the hypotenuse of a unit circle is always 1, then the other sides are going to be smaller than that. Now, again, circular function, because you're going to move this around in a circle, and in fact, that's why you get a picture that looks like this. Okay? We have 0, 30, 45, 60, 90, 120, 135, 150, 180, 210, 225, 240, 270, etc. all the way around. Then you have their radian measurements. And then you have these x, y's that go with them. But there's no reason to memorize all that. All you have to do, of course, is draw a picture. Now, another little tidbit of information. Earlier, we did sine inverse of -1 over root 17, and it came out -14 degrees. The reason it came out -14 degrees is because each of these has to be a function. Well, sine has a graph that looks like this. Up to 1, down to -1, pi, 2 pi, up, down, up. Okay? That's the graph of sine theta. If I try to do its inverse, remember, we switch it over the line y equals x. And so that means we would have, and this would no longer be a function. So what they do is anytime in math class that we have a problem, we have to come up with a solution. So sine inverse of theta, we don't use any of this bit up here. What they say is they take this bit, which is okay, which is really nothing more than 0 to 90, and they take this bit, which is okay, and that's to -90, okay? So they only take from here to here, which is why anytime you do the inverse, it will only give you values somewhere between -90 and +90, or negative pi over 2, positive pi over 2. That's true for sine, that's true for tangent, and I believe cotangent as well. Now, if you had cosine of x, 1, -1, it's drawn like this. And if I try to find the inverse of that, that's going to look as the following. And I can't keep going because then it's not a function up here. But I can take from here to here, which is from 0 to 180. Okay? So, cosine, we call them principal values. Cosine is always going to be somewhere between, cosine inverse of theta is only valid for thetas from 0 to 180. Sine inverse of theta works from negative 90 to positive 90. Okay? That's why those come out the way they do. They're called circular functions. And trigonometric functions, that's why the graphs behave as they do. This is really just a primer for when we do this a little more hardcore coming soon.